Welcome to Auto Talks Energy, Episode 2, the Petroleum Industry. I'm really excited about this episode because I often wonder, where does my gasoline come from? I mean, I have a vague idea where we dig oil and somehow we get it to these huge plants with a bunch of steel pipes and somehow it makes its way to my local gas station. But the process was very elusive for me. So this project was really intriguing because I got to learn more about the details of the industry, and I hope to share them with you today. But before we get started today, I wanted to answer one of our viewers' questions. John writes, "How does oil fertilize my food?" referring to a comment I made in the last video. Well, John, petroleum doesn't directly fertilize food. I didn't provide the whole explanation. Petroleum provides a feedstock for the production of synthetic fertilizer. And the one I was thinking about in particular is ammonium nitrate. Ammonium nitrate is a power fertilizer used everywhere in the world. And it's formed from ammonia, and ammonia is formed from a combination of nitrogen and hydrogen through the Haber-Bosch process. Now the nitrogen comes from the air, but the hydrogen is sourced from methane, and the methane in turn comes from natural gas and oil wells. So I hope that more fully explains how I made the comment or the claim that petroleum is used to provide for our food production. Alright, moving on now to the main event for today, the petroleum industry. The petroleum industry has three big parts. We've got a upstream part, a midstream part, and a downstream part. The upstream part is really about exploration and production. The midstream portion is about transportation and storage, and the downstream portion is all about refining and processing. Now first, a little bit about the upstream portion. But to really get a sense of how this works, I need to first explain how oil is formed to begin with. Oil is the product of millions of years of compression and heat exerted on an enormous mass of organic material. Organic material like algae and plants and animals and anything that has carbon and hydrogen. These huge masses of organic material are subjected to miles of earth and 100 to 300 degrees for millions of years. And that material decomposes into oils. Now, crude oil is not just one thing. It's a combination of all kinds of hydrocarbons, from the light stuff like methane, pentane, butane, to heavier stuff like gasoline, kerosene, and diesel, to the really heavy stuff like waxes and asphalt. When these materials are in a single location, they will tend to move closer to the surface because they're still lighter than water. So that brings me to the next point, which is, how is the reservoir of crude oil contained? Well, to have an oil reservoir, there needs to be two things. One, there needs to be a porous rock to contain all of this liquid. And that could be something like a sandstone, a shale, a limestone, anything with either cracks or high porosity to allow the oil to stick to. And the second thing that there has to be is some kind of cap rock, an impermeable layer on top that prevents the oil from just seeping right through to the surface. So that explains the kind of formation that has to exist for oil to be contained at a single site. So the next question might be, how do geophysicists and geologists know where to drill for oil? Well, they can look for these particular formations by virtue of, one, the type of rocks they find, if there is a reservoir rock, and the geological formation that may suggest a kind of cap. But these two clues are not enough by themselves. The next step is to drill an exploratory well, a wildcat. So a exploratory well is drilled, and imagine my arm is the well bore, and this provides access for instruments to be dropped along the well bore to take measurements. Now, of course, they can also pump out whatever contents are below to get a sense of the quality of the oil, but they'll also measure things like electrical, acoustic, and nuclear magnetic resonance, gamma ray imaging, all kinds of various logs to profile the kind of geology that's present along the depth of the well. And in doing so, they're assessing the quality of the reservoir. If the exploratory well proves to be promising, then this well can graduate into a kind of production site. But that's not it for the upstream process. In addition to exploring and finding the well, there has to be production facilities built. And the production facility is more involved than exploratory well because it's a much more sophisticated setup. Instead of a single well that extends vertically, a production well may come down a few miles, then extend out 7 miles, and it may be just more than one line. It may fan out in 24 different holes. So that means that a small footprint on the surface could extend to something like 200 square miles below the surface. And that's all part of the upstream process. The next part is the midstream process, which essentially takes the oil from the point of extraction to the refineries. So first, need to reiterate that oil is not just a single thing. It's a combination of hydrocarbons of various molecular weights, but it's also composed of contaminants like water and sand and sulfur and other things that we don't want to take to the refinery. One of the midstream processes includes removing these contaminants. The natural gases are also removed at this point. They can be sourced to a different kind of facility that handles natural gas, where refineries typically include only hydrocarbons as low as methane. The next thing to discuss is modes of transportation. We already said that we needed to get the oil from the point of extraction to the refinery, but there's different ways to do that. Pipelines are the most common and safest way to move oil, but there's also railroads and ships. Now, railroads are common for intracontinental transport, but in looking at international trade, supertanker vessels are the preferred transportation type. These supertanker vessels are enormous. They can contain 2 million barrels of oil in a single vessel. That kind of movement is just unfathomable. Huge amount of oil. The midstream also does something else that's important. It stores oil. Now, this is a relatively new thing in the petroleum industry. Oil storage on a large scale was encouraged by market fluctuations. In fact, the strategic reserve that the U.S. uses was in part created to answer issues like the oil embargo of the 1970s. This is a facility that collects enough oil to meet our demand in the United States for as many as 30 or 35 days. It's nearly 1 billion barrels of oil in a single location. But companies can also use oil storage in the midstream process. And they would do this to hedge against oil price changes. So what does that mean exactly? It means that when oil is cheap, they choose that time to buy oil. And when oil prices are high, they will sell off their oil. And that helps markets levelize the cost, stabilize costs, and it definitely helps the consumers at the pump because we don't see the changes as drastically. So that's a little bit about the midstream process. Finally is the downstream process. And the downstream process is primarily refining oil, but it also includes marketing and sale of the petroleum products. So first about refining. Refining occurs at a distillation tower, an enormous tower that uses heat to separate the crude oil into its constituents. And as we discussed before, the constituents are various molecular weights of hydrocarbons. So at the top of the tower, we may find things like methane or other gases, butane. But as we go down, they are heavier. So we may have alcohol, gasoline, kerosene, diesel, light heating oil, ship oil, waxes, and things that wouldn't be used for anything other than paving roads. These various fractions are then directed to different petroleum product lines. Now, if we left it just at that, we would end up with a modest amount of gasoline and a lot of other products. But gasoline is the primary product we want out of crude oil. So to sequester the other fractions into gasoline, there's additional processes at the refinery that help us do that. One of them is called combination or polymerization, where the low molecular weight compounds are broken, or rather, they're put together to form bigger pieces that can belong in the gasoline blend. And conversely, there's a process called cracking that will take the large molecules and it'll break it apart, and then it can become a constituent inside the gasoline blend. And in doing this, we get more gasoline per barrel of oil, and that helps us produce our number one most popular product, gasoline. So a little bit about the products that come out of a refinery. The number one most important one, of course, is gasoline, followed by diesel fuel. But the other products include things like ship oil and kerosene, jet oil, alcohol, and methane. And a lot of these different materials are then feedstocks for other processes, such as the production of plastics, or like I mentioned earlier, the methane may be diverted for use in fertilizer production. So that's a little bit about the products that come out. After the refining process, the petroleum products go to various different places. But in following gasoline, they travel through the pipelines to distribution centers where tanker trucks deliver that fuel to our gas station, where we get it. So that describes a little bit about the downstream process. Now I've got to add a little caveat, because all three of these processes slightly overlap, and some of them perform functions that the other would sometimes too. So that's a little bit about the petroleum industry, and I hope you learned something too, because it was very fascinating for me. So I hope that you also picked up on some interesting notes. Join me next time when we talk about the electricity industry. And don't forget to subscribe, thumbs up, and leave me comments and questions so we can explore topics together. Thanks for joining.